I thought this Howtheseimpossibly thincutsaremade stevemould.
This piece of metal is an offcut from a machine shop. There doesn't seem to be anything unusual about it until I push this piece out. How amazing is that? Until the part is pushed out, it's as though there is no seam at all. Look at this one. This is called a Metmo cube. What's cool about this is there are actually two parts that slide in and out, and internally they're connected via a small borehole. So when you push one of them down, the other one pops up. It's very satisfying. But like, how on earth is one of these things made? How can there be almost no discernible seam between these parts? Well, these curiosities are made with a technique called wire EDM, or wire electrical discharge machining. Wire EDM is used for all sorts of useful things. These curiosities aren't useful as such, but they're a good way to demonstrate the ridiculous precision of wire EDM. You may have seen other examples of this online. When I did, I became obsessed with figuring out how it was made, and more importantly, getting hold of one. There are actually a couple of really clever tricks involved in the manufacture of these invisible seams. Like when I heard that these were made by a process called wire EDM, I immediately got distracted by what I assumed that must mean. I just thought, oh, right, it's like a cheese wire. If you want to cut a circular hole, then you drag the wire across into the cheese, cut the circle, and then carefully pull the wire out. Or if you don't want this cut here, you first drill a hole in the cheese, we've all done it, feed the wire through, reattach it, and then do the cut.
That is
Another good
nice.
analogy is cutting styrofoam with a hot wire. The wire melts the styrofoam. It's quite therapeutic, actually. There's a problem though. You either need to have a cut in this part or a cut and a drill hole in this part. But neither of these seem to have those cuts. Also, look how much wriggle there is there. That's at least 0.5 millimeter. Whereas here, there appears to be no apparent clearance. Like, how thin is this flipping wire? And actually, that's the first trick. This is actually made from two separate bits of metal. First, you cut the hole, then separately, you cut the part that goes into the hole. And you just have to make sure that you compensate for the thickness of the wire so that when one part slides into the other, it's a nice snug fit. And actually that's something we can see with this part because the piston was actually cut from over here. And if I put that piece back to where it was cut from, you can see the wriggle room. Measuring with calipers, it's about 0.2 millimeters all the way around. That's consistent with the width of the wire. And look, there's that unavoidable cut line. I managed to do the same thing with the cheese, actually. Fits perfectly. Now, what about this second trick? Well, we'll get to that in a moment, but first, how does wire EDM work? I went to a machine shop called Travelling Wire in West Sussex to find out. So this machine does EDM without a wire, and it's a bit easier to see what's going on actually. So this is the part, and this is the tool that's going to cut into the part. Except it's not cutting in the normal sense. The way it works is you put a really high voltage between the tool and the part, so that if they were to touch, it would complete the circuit. But in reality, the voltage is so high that the part and the tool wouldn't need to touch. They would only need to get close enough for a spark to jump from one to the other. And every time a spark jumps, it erodes the surface of the part slightly. For the purposes of EDM though, you don't allow the spark to travel through air. Instead, you surround the part and the tool with an insulating liquid. The liquid has well-controlled properties, so it breaks down at predictable voltages and distances. It's also a better heat sink than air, keeping the bulk of the part cool to prevent expansion. Why does an electrical spark erode a contact point though? Well, interestingly, we don't know for sure. One possible explanation is heat. When there's a spark, a huge amount of electrical energy is converted into heat energy in a very short period of time. So the metal gets very hot very briefly, and some of those metal atoms will vaporize away from the surface. So if you want to etch away at something, this is the tool for you. But if you want to slice through something, you need a different tool. That's where wire EDM comes in. This is one of Travelling Wire's wire EDM machines. By the way, check out the link to Travelling Wire in the description for all your wire EDM needs. They're not paying me to say that. So we want to cut out a little bit of this sheet of metal here. There's already a hole in the middle, so we can feed the wire through there. This jet of water helps to guide the wire as it's being fed in, and once it's through the hole, some machinery underneath grabs it. The whole thing is then submerged in water. Actually, water is only a good insulating liquid if it's free of ions. So this water is deionized. There's a machine round the back that takes tap water and this special resin. It does something with it and pumps out deionized water. Unfortunately, once the sides of the tank are up and the thing is filled with water, you really can't see what's going on. Not that it matters when you've got a brilliant cheese analogy. One big difference between the cheese wire and the EDM wire is that the EDM wire is constantly moving. These pulleys are constantly turning, and if we go around the back, you can see it's being chopped up and spat out. That's because the wire itself erodes as well as the part you're machining. This spool here contains about 10 kilometers of brass wire. And look, there's the part now, cut out exactly how Richard here drew it in his CAD software. You can also angle the wire in clever ways, so you can cut tapered parts and holes that have a different shape at the opening than they do at the end. You can do all sorts of cool stuff with wire EDM. But what about that second trick? Well, look, here's the first part that I showed you when it's halfway through the manufacturing process. The piston is already cut out and it fits perfectly. But look, because it was cut from a different part of the metal, you can see it, right? You can see that it's a different piece of metal. So the final trick is to polish, or grind really, the two parts together in situ. By grinding the two parts together in this way, they obtain a matching finish. The grain of the abrasion pattern flows seamlessly across the seam. And so it seems as though the seam can't be seen. And look, you can achieve the same thing with cheese. Even knowing how this is done, the precision is unbelievable. A typical wire EDM machine will have a precision of around 5/1000ths of a millimeter, which in inches is a different number. Why is wire EDM so precise? Well, it's mainly because the tool and the part never touch, so they don't perturb each other in the same way that you get with an abrading tool. So there you go. Wire EDM. The mechanism that joins this thing to this thing is really clever, but not in the way that you might think, and actually not in a good way. In fact, it's in an evil way. Let me explain. The mechanism is just complicated enough and just novel enough to be patentable. That means no other manufacturer is allowed to make blade cartridges that go with this handle, which means if you buy this handle, you can only buy blades from the same manufacturer at a significantly inflated price. The same thing is true for single-use coffee pods, the same thing is true for the heads of electric toothbrushes, and amazingly, the same thing is true for the uranium rods that go into certain nuclear power plants. Like, wouldn't it be nice if you could just pay a reasonable price for your nuclear power plant, and then you get to buy the uranium rods from wherever you like? Wouldn't it be nice if you could pay a reasonable price for a really well-engineered razor blade handle, and then you get to buy the blades from wherever you like? And actually, even the really good quality ones are just pennies. And that's the idea behind Howtheseimpossibly.
Yes, I think then they also could understand, I guess.